All right, well, hello and welcome to the Box Messaging Hub Active and Continuous Operations webinar. My name is Stephen Spear and I'll be guiding you on this kind of high-level journey of what we provide within the Box solution to enable you to truly have assurance that in the unlikely event of a failure, you have the setup in place that will protect you and allow for continuous operations of your mission critical infrastructure. So let's take a look at today's agenda. And we will start by taking a look at the overall solution that Intercope provides to their community and what the key benefits are if you implement the active architecture and solution. We'll then take a quick look at the components overview, which should give you a decent understanding of what needs to be in place and really why you have to have certain components in place to truly make this an effective proposition. For module groups and instances, we'll dive into these Intercope specific terms and show you how these are built within the Box environment and how you can control the components either manually or autonomously based on your given preference. And then on to arbitration. Now this is a fairly heavy topic, so I'll try and cut through some of the kind of technical weeds, so to speak, so you can see how the principle of arbitration is the system's ability to talk to the individual components to make a decision on who stays as a standby node or component and when to become active. For continuous operations, now what does this exactly mean? And we'll take a look at how all of the decisions taken during arbitration equal an autonomous approach to keeping this system operational at all times. And at the end of the day, any manual intervention results potentially in an increase in downtime, and that is really what we want to mitigate here. For basic system setup and requirements, pretty much speaks for itself, I think, and I'll give you an example of what that might look like in your environment and what the minimum spec really should be to gain that level of assurance that I mentioned previously. Now for the last two areas, module configuration and instance configuration, we'll take a brief look at what this looks like from a system GUI and an internal configuration point of view. And this really should show you that a lot of the issues from the past when it comes to configuring a system of this nature is reduced considerably with the implementation of Box. And I've mentioned it already in previous webinars. You don't have to completely trust what I'm about to say. If you have any questions or concerns about what I'm about to cover, please reach out to me and I'll be more than happy to give you the contact details of our community customers who can also be used as our reference customers. And they'll truly give you the right kind of reflection of the solution and how it worked for them. So there are a number of areas that we need to look at. So let's get started and we'll immediately jump into what the key benefits are of not only implementing the solution provided by Intercope, but of course, any solution out there today that gives you the peace of mind of a setup that can give you true continuous operations. Now there are a number of solutions on the market today, however, not all of them contain or provide you with the level of active features that cover all aspects of your system's architecture. So rather than looking at a very complicated schematic overview of what a system's architecture should look like to give you complete assurance, let's look at it from a different angle of what is it, what you truly require, what ticks all of the boxes that you may have on your continuous operations roadmap. So let's go through some of those items here. So 24/7, of course, you want your environment to be truly available 24/7 without any downtime unless it falls within a change window. Of course, there are institutions that we work with today that cannot have downtime at all. And we cover this in a separate webinar to show how Box can be positioned for automated implementations from development through testing and into production without the systems having to go into a planned downtime window. Again, for us, the key is continuous operations, not only when a failure occurs, but also when you are required to perform an action. So no service interruption if one or more components fail. The solution has been created to not only handle this with ease, but through arbitration, make those decisions quickly so you don't have to. We need to ensure that your messages or files are still being processed, not only if there is a component failure, but also if there is an external component failure. For instance, if a Swift SAG were to fail, we need to guarantee traffic distribution until the situation has been normalized. Usage of a clustered database. Now this is key in terms of implementing a box solution. There are a number of prerequisites that need to be in place to allow you to gain the most out of the solution. The database is key to this on a number of different levels, not only from continuous operations, but a number of additional key benefits which only Box as a solution provides. I won't go into too much detail here, but again, take a look at the Intercope website, and in the collateral section, there's a lot of great information there for you on what those benefits are. What's important to remember here is that we strongly recommend a database cluster which secures your data, stores messages and your configuration, and without this in place, you're definitely going to see an increase in your risk profile with your current solution. For WebSphere MQ cluster support, for those of you sending transactions in the millions per day kind of figures, you'll have a set of MQ queues being used for input and output of messages. However, if you only have one set of queues connecting to an individual instance, then this has the potential of being a single point of failure. If you set up Box to be completely resilient on all levels, then you need to make sure that your back office mechanism for feeding messages in and out is also resilient and fault tolerant. In terms of monitoring, now we want this to be easy, self-explanatory, and integrated into whatever platform that you use today. From an operational perspective, we want to be alerted to issues immediately and not have to dive into the weeds of an investigation to analyze and work out what has gone wrong. We want this to be performed by the solution, so you are provided with the resolution and action even before you've had a chance to look closer. Again, arbitration with a focus on speed and efficiency. And scalability and resilience. Now your environment will grow and the complexities will change over time. So building the correct foundation from the start will provide you with the right set of building blocks to scale quickly if necessary and ensure resiliency is kept to the highest levels at all times. So let's dive into the component overview and we'll go through each individual group and instance which are defined within the Box solution. Now, a number of these are very specific for the Intercope Box product. Now, it's key that we have an understanding of the terminology and its usage. For module groups and instances, to be able to truly implement an active-active solution, the concept of module groups was included in the architecture. A module group, now it combines logically linked modules into either an active-active or an active standby configuration. So in terms of what you see in the picture here, an instance can be classed as an individual node within a system, and the module groups are the components required to run the system and the tasks which are then built within the solution. At this point in time, the names here will not mean a great deal to you, of course, but we'll go over just a few of the items. The IPNS, the stub, the monitor as examples are integral parts of the system. And in the setup, they can run either active-active or active standby based on your requirements. Now, in terms of what is configured to be active-active or active standby, this comes down to your individual needs, but also recommendations that will be provided during the analysis phase of the project with us. It also comes down to requirements of the individual module groups as well. Now, if a monitor module, as an example, were to fail, this of course would not be detrimental to message processing. And because of this, you may not be required to configure a group of this nature as an active-active group. Now, if we take a look at the module types, this pretty much covers the last point that I just made. You can see within the table what the module is called, how it is configured in terms of being an active-active or an active standby component, where it in terms of configuration is located. So you can see that in this example, the server configuration is the only module type set to be active-active with its configuration held within the database. You can also see that any component that will require arbitration at some level is also held within the database and also on a shared drive. And any individual component with no linkage across instances can be configured as a standalone group with no failover capabilities. Now it's worth us taking a look at the individual modules to at least gain a sense of what they're used for and how they fit within the overall picture. The central server, or SERV, is one of the key modules built within the system. Now it's used for all administration tasks on messages or documents prior to being dispatched, ready for submission. It's also used for report generation and routing order generation in terms of the workflow of the message. Now there may be a number of key steps that need to take place prior to a message being submitted, of course. These could be additional validation checks, external application processing, anything that requires a set sequence or order of execution before the message is released. This all takes place through the central server, and as we saw in the last slide, it has an active-active configuration linked directly to the database. Now for the IPNS, or IP name server, now it's used to handle the assignment of TCP ports, which are used by the server modules, along with the mapping of names to specific TCP sockets. Now the IPNS, it must be started as the first process of the overall module domain, so that's all of the components. As the other components will register with the IPNS and then initialize the communication with the other components by using services which are provided by the IP name server. And it's worth noting that the IPNS module is the only module that uses a fixed port, which is 1066. All other modules provide their names to the IPNS, who in turn assigns the TCP sockets. So in terms of integral components for continuous operations, the stub module can be seen as being pretty high up on that list. Its job is to execute stop and start commands that are sent by the monitor module, and we'll look at the monitor module shortly. It also starts services, so if you're using Windows, or it can trigger shell scripts on Unix environments on a single instance system, or a distributed installation where components run on different computers. Each system must have a stub module configured, as you can't issue start or stop commands directly from a remote system. Okay, now the monitor module. As we touched on, it controls and it monitors the overall domain. Now it will trigger the start of all components that it finds within the configuration of the domain, and it continuously receives heartbeat signals from all active components. So if a component were to fail, that failed component would trigger the monitor to use the stub module to automatically restart. Also, on the basis of signaling a domain or a system shutdown, the monitor through the stub will send a signal to all components so they can shut down their operations in a controlled sequence. So a very important part of the overall picture, of which we are just touching on really at this time. Now when we look at communication gateways, now their main purpose is to administer communication channels and orchestrate the transmission and reception of messages and files. From a reporting perspective, it can also be used for the transmission of reports from the central server to external applications. Now there are a multitude of applications that the communication gateways can kind of integrate with. Now they are from Microsoft Exchange to SAP to IBM DB2, Content Manager, just to name a few. And also customer specific applications through their middleware like RDBMS, WebSphere MQ of course, or a file gateway mechanism of their choice. Okay, now when we look at the formatting of information, the central server will be used for internal or external rendering or formatting. However, when execution of formatting is required on a remote system, a DRM or a document rendering module will be installed, which will be triggered by the active central server. This gives you the flexibility to implement multiple DRMs to combat any performance or bottleneck issues that may result from multiple formatting tasks being completed at the same time. Now in terms of active-active, this doesn't really play into the picture, but it's worth noting its linkage with the central server here. Okay, when we look at web applications, now the Box Web Client, it's a pure web application. And what do we mean by that? Well, it means that the application does not require the installation of additional code on a user's environment. It's platform independent. The only prerequisite, so to speak, is that it requires a standard web browser. The client is highly customizable. It's based on the individual customer's needs. And once again, in terms of an active setup, this probably isn't directly related. However, the web client does access data objects and communicates with the central server. All of the communication takes place via the database. And to be able to achieve this, signaling must be established across all active modules on their respective nodes. Now, in a shared system configuration, the web client must be identified uniquely from another instance. And this, of course, is configurable within a configuration file, which specifies the unique ID of the Java API. In fact, the configurable parameter is a single parameter called system.vmid, which looks for the name of the box client. And for you administrators out there, now we talked about how the IPNS is used to assign TCP sockets from the names of the modules. Now, one question might be, how do the names become associated with a specific module? Well, that is what we can see here. Each individual module is identified by a 4-digit module ID and by a 2-digit service ID. Now, the module ID is defined in the startup configuration of a component and must be unique for all components which carry the same service ID, such as multiple communication gateways, as we touched on earlier. Now, service IDs are fixed and are specific for each type of component. An instance number is also assigned now, as you can see here, for each module. Now, this is defaults to 1, but it can be set during the configuration. So if we look at the example here, we can see that the IP address ending in 76 is assigned to module ID 0001, service ID A3, and with an instance number for the first entry here, which is the default 01. The default name made up of the module ID, the service ID, and instance number would then be 001 A3 01. Now, the majority of modules have a set service name, and in this instance, A3 is the service ID of the monitor module. Now, this would change, for example, if it was the central server or SERV, which is associated to B3. Okay, so we've taken some time to get a basic understanding of the components, the modules, the instances that are required to run the Box application. I would suggest that you go through those last 12 slides again, see if you can gain a better understanding of each of the different components that are within the Box application, what it's used for, because I believe that'll really help you when it comes to understanding how we implement continuous operations. Now, I think the question I'm sure all of you now have is, how do you take all of that and use it, as I mentioned, in terms of active, and continuous operations? Well, to understand that, we should first take a look at arbitration, what it means and how it plays its role successfully within the solution. So as I mentioned, arbitration at the start of the webinar, the key principle or process of arbitration describes the negotiation between modules to become active or remain in a standby mode. Becoming active also includes the taking of full responsibility for the processing of messages or files where the owning server has become inactive. Now, to be able to do this effectively, all members of a module group jointly agree on their role and responsibilities within that group. And one key point is that all arbitration data should be maintained in a table of the shared database. And in this slide, you can see details of the module arbitration section, which contains, in this example, just the node 1 and 2 details and the associated parameters which result in an action from either a module timeout, a module update, should a takeover take place if a timeout occurs, and even if a takeover should be cancelled if a node is stopped. All of these parameters, and these are but a few examples, have to be triggered from a status transmission or status parameter through checks on heartbeats or signaling, as a couple of examples here. Now there are, of course, a multitude of status checks. However, we've listed the main status parameters here which should trigger an action. The member status, or the current status of a specific member, be it a node, a module, etc. within the system. The master role assignment of who currently has the active role of being the master. The message processing map, who out of the potentially multi-active members is processing the pending messages. And message processor, the arbitration takeover result for pending messages of a member. Now, in terms of actually performing a takeover, we have to avoid concurrent message processing on different central server instances, of course. Data integrity has to be our #1 concern here. The takeover process has been implemented to support a stateful architecture where another central server module continues the processing on behalf of the unavailable module group member. Now, this requires the requeuing of active messages, issuing delivery notifications, and response handling and processing of asynchronous external responses such as embargo screening. Now, in terms of what you actually see through the web client, and what you see here is a representation of what a small box environment might actually look like. You see the level of granularity that can be achieved in the monitoring of module groups, and also the combination of true active groups along with active standby groups. Now, for the central server multi-active group, there needs to be a master assigned to allow for a secondary node to be assigned as master in the event of a failure. All of the screens, of course, are highly customizable based on your operational monitoring requirements, of course. And you can also, if required, see a lower level representation at the cluster node level for all instances and groups, as you see here. Now, it's also worth highlighting that what you see here is, of course, the representation through the web client. All of the details here can be fed into SNMP or other protocols to then be sent to your internal monitoring systems. This doesn't take away the effectiveness of the internal arbitration, but it gives you the flexibility to monitor and control outside of these default views. Now, this of course is just the high level details of each module group. Now, if we dive a level below the current level, which may help you understand what a failure resulting in a takeover actually looks like, you're met with a screen that looks very much like this. Now, each module group contains details which reflect the configuration of the arbitration. Along with this, each module role within the system can also be viewed. Now, the box central server details also contains the processing map, which allows the user to identify the message processing module and then change the respective box server module to take over the processing by means of resetting the processing map. Now, in an active standby configuration where there is no need for a processing map, visibility is only really required at the node level for who is currently active and who is available as a standby node in case of a failure. Now, if you are planning to use an active environment, as mentioned previously, there are a number of key recommendations we will provide to ensure that you don't have any single points of failure. You need a heartbeat mechanism. Now, that preferably is configured at the database level with an arbitration table which provides configurable status updates. Now, it's also highly beneficial to have MQ signaling when connecting central server modules, of course, to box MI modules. And it's also possible to configure database signaling. Now, this will require the introduction of additional tables within your database. And clustered MQ managers, which connect to each node either with a primary or secondary connection, allowing for clustered queue management. So you have a number of areas to look at, which all provide additional layers of redundancy. I would recommend scheduling a meeting with Intercope to go over these options and see what best fits your organization. So let's look at a practical example of a takeover, and I think the slide here shows it very well. The initial status of the environment provides us with a view that shows that all modules are operational. Now, how do we know this? Well, we know this because we see a clear master status for node 2. You see the M there within the master column. The timestamp of the status is current, and we have a message processor timestamp of the last message processed by both active nodes. In the second picture, we now see that the primary central server holding the master role for some reason has become unresponsive. It's not available anymore for processing. We see this in red here. We don't have a current status, which is now overdue, and the identification of the node is now amber. With the master node reporting unresponsive, there is now an automated, which can also be manual of course, but an automated switch of the master to node 2. And you can see in the bottom image that the master status has now switched to node 2, but also that the processing map now shows both nodes, that's 1 and 2, are now processing traffic from the same system. Now, we've shown how this can take place with a central server failure, but this is of course the same approach used for any active module group. Now, in regards to the processing of messages, you can see here that for some reason the primary central server with the master status set has been excluded from the message processing, and the respective messages are now being made available for the other group member. What's key here is also that you can see in the message processor that the system is waiting for arbitration to complete. You see that on the right hand side under the message processing column. The system has to perform a number of checks to ensure any reconciliation is performed before being able to start actively sending traffic. Now, once all checks are finalized, the module is stopped, resulting in a red status in the identifier. The master role moves to the secondary box central server, and the processing map is updated to show that all processing is now taking place through the secondary node. Now, this really provides a true active environment at the moment in time when a takeover takes place. Now, we are not concerned about the status of the failed or failing system. Now, we're more concerned with making sure that any operational impact is removed from the situation, so that number one, there is no downtime created, of course, but also that there is a fully automated process which allows for the removal of potentially over-analysis, I would say, or additional manual actions. Get the system working with no downtime, and then fall back and investigate the cause. Now, I think I've mentioned on multiple occasions now that there are certain items that are required to be able to implement a true active solution which enables Box to run in an arbitrative mode. Now, the most basic setup would include 2 servers or nodes running Box with connectivity to a shared database where the database can be run potentially from one of those servers. This would be the basic minimum advisable setup, and we generally will not see this for the larger tier 1 institutions. Now, all 3 individual parts must be maintained and updated to result in the same release of all Box components, such as the database, the client and server. And as both Box servers will contain the same setup, including all configurations, it's recommended, again, I think we've said it a few times now, that you maintain all configurations centrally within the database. And this can be achieved using the inbuilt scripts which are provided with the Box solution. So again, in this slide, what you're seeing here are the bare bones, the bare minimum requirements for you to have an active solution in place. Okay, so let's look at module group configuration, and I don't want to go into too much detail here about the actual configuration and its parameters. This is something we would do through planning with Intercope and the customer to make sure that the configuration that we put together is right for that particular institution. But I do want to briefly show the level of detail that can be provided and the simplicity in the configuration. So in this example, you can see on the left the items being configured within the arbitration configuration. The module groups can be seen here in the format of what you see within the configuration file, which provides granularity at the level of redundancy that you require. Now, as an example, at the top, So the top left entry, and we talked about it earlier, this is the IPNS, which is used at system startup. Now this will run independently on the individual nodes. So within the configuration, there is no need to have a relationship between the module at this level. Now take that into comparison with the bottom red entry. Now this is the entry for the central server, which is actually running in an active configuration. And what you can see here is the ordering in the preferred master role parameter to who takes that position at startup. Now once the configuration is loaded, you can see then with the interpretation on the right hand side through the web client the actual module groups themselves. Now the same can be said at a more granular level, where you see the true results of the configuration from the module group name all the way down to the processing map if you were to click on the show details buttons on the right hand side. Very easy to read, very easy to associate the entries with the GUI views. Alright, so that really is the extremely high level kind of whistle-stop overview of what arbitration within the box solution looks like and what real-world benefits it can provide to your institution. If this has now hopefully triggered some interest and you'd like to look at this in a lot more detail, please feel free to reach out to me at the address on the screen now. For anyone looking into the true benefits not only of a solution that provides continuous operations but also provides the necessary requirements of a messaging hub, although these are separate discussions, we will be more than happy to organise workshops to cover all of these aspects. So with that, I'd like to thank you all for joining, and I hope this has answered some of the questions that are posed to us from our community. So thank you very much for joining.